All right, let's pull back the curtain on one of the coolest pieces of tech running our digital world, the knowledge graph. It's really the secret sauce that makes so many of the online tools you use feel incredibly smart and, just intuitive.
Have you ever had that feeling? You type a few words into a search bar, maybe something kind of vague, and somehow, bam, the results are exactly what you were looking for. It's not magic, but it kind of feels like it, right? Well, that's exactly what we're going to break down today.
So here's the plan. First, we're going to cover the absolute basics. What even is a knowledge graph? Then, we'll get into the detective work of how you pull knowledge out of plain old text. After that, we hit the really cool part, the semantic knowledge graph. And finally, we'll see how this all comes together to power things like search and recommendations.
Okay, first things first. Let's start with the foundation. What are we actually talking about when we say knowledge graph?
At its core, it's actually a pretty simple idea. Just think of it like a giant relationship map. It takes things, people, places, ideas, anything really, and it charts out how they're all connected. The key takeaway here is that it's not just about the things, it's about the connections between them.
And this breaks it down perfectly. A graph has just two main ingredients. First, you've got nodes. Those are the entities, the people, the places, the concepts. Think of them as the nouns. And then you've got edges. Those are the relationships that connect the nodes. Think of those as the verbs, like wrote, presented at, or located in. That's it. That simple structure is the backbone for everything else we're going to talk about.
Okay, so if a knowledge graph is a map, the big question is, how do we draw it? Where does the info come from? This next part is kind of like detective work. We're going to figure out how to find and pull out facts that are hidden inside mountains of messy, raw text.
And this is the real challenge, isn't it? We have all this text data out there, but how do you teach a computer to read a sentence like "companies employ data scientists" and actually pull out a structured piece of information from it?
Now, there are basically two ways to go about this. On one hand, you can just grab any verb and call it a relationship. This is super flexible and really powerful, but as you can guess, it can get messy and inconsistent real fast. On the other hand, you can be very specific and only look for is-a relationships. That gives you a super clean, well-structured graph, but you end up missing out on all the other interesting connections.
But here's the catch with both of these methods. When you pull a fact out of a sentence, you lose all the context around it. The fact is just floating, disconnected from where it came from. It's a lossy process, and that limitation really sets the stage for a much, much smarter solution.
And that solution is the semantic knowledge graph. And I'm not kidding when I say this is a total game changer. It's a completely different way of looking at the whole problem.
I love this question because it just flips everything on its head. Instead of going through all that hard work of extracting facts and building a separate graph, what if we just realize that our text data, exactly as it is already a gigantic interconnected graph?
This whole idea comes from a fundamental principle in linguistics called the distributional hypothesis. Basically, it just means that you know what a word means by the other words that hang out with it. Context is everything. The word Advil shows up next to words like pain and ibuprofen way more than it shows up next to road trip or cooler.
So the huge mental shift here is to stop thinking of text as just a flat line of words. It's not unstructured. It's a massive, hyper-structured web of connections. Every word is a node, and its relationship to the words around it forms the edges. The graph is already there. We just need to learn how to read it.
So how does this actually play out? Well, it's this beautiful, simple two-step dance that happens on the fly. First, you start with a term, let's go back to Advil, and you find every single document that mentions it. Then, for step 2, you look only at that group of documents and ask a simple question. What other words show up here way more often than they do everywhere else? And just like that, without building anything beforehand, you've dynamically discovered all the related concepts.
Okay, that's the theory. Now for the fun part. Let's put this thing to work. This is where the rubber meets the road, and we get to see how this awesome technology actually powers the smart tools we use every single day.
Let's use a fun, nerdy example. The word vibranium doesn't exist in the real world. You won't find it in a dictionary, so how on earth does a search engine figure out what you mean and give you good results? And look at this. By doing that exact two-step dance we just talked about, the system automatically figures out the context. It finds terms like Wakanda, adamantium, and Wakanda because those words always seem to be in the same articles and web pages as vibranium. It literally learned the meaning just from the context. It's incredible.
This technique actually has a name. It's called query expansion. Your search engine doesn't just look for the keyword vibranium. It gets smart. It rewrites your query behind the scenes to also look for all those other related terms. That's why your results are so good. It's searching for a concept, not just a string of letters.
And you can apply this same logic to build amazing recommendation engines. A system can look at an article you're reading, figure out its main concepts, use the semantic knowledge graph to find related concepts, and then create a brand new query to find other articles about those same ideas. It's how You Might Also Like can work so well without needing to track your personal data.
So, can we push this even further? Can it handle more complex, more arbitrary, more, human relationships? For example, can it figure out who is in love with the X-Men character Jean Grey just by reading text?
And the results are just fantastic. I mean, look at this. By simply finding documents that have both Jean Grey and the phrase in love with, the system finds all the key players. You've got Summers, of course, who is Cyclops, and Wolverine. But it even picks up on Xavier and Magneto, who have these much more complex relationships with her. The system modeled a really deep human concept without anyone ever explicitly teaching it what love means.
So let's just quickly recap the big ideas here. A knowledge graph is just a map of things and how they're related. You can build that map by hand, but the much more powerful way is to use a semantic knowledge graph, which just treats your text as the graph and discovers connections on the fly. And this is the engine that's driving smarter search and better recommendations everywhere.
And that kind of leaves us with one final big thought. We've gone way beyond simple keyword searching. We're now in a world where computers can start to understand context, ideas, and all the nuanced relationships hidden in our own language. So the real question is, now that this is possible, what kinds of new, bigger, more interesting questions are we going to start asking?